here is how to perform data recovery by Flash Doctor. So first of all, I will introduce what is the page structure in the Flash. So the page is a minimal read and write unit of the NAND Flash, and which equals the sector of the hard disk. So the page is just similar as the sector in a hard disk. Okay, and the page structures varies due to different flash memory chip. So here is some common page. There should be 2112 and 4224 and 4288 and 8600 is a common page for the flash chip. So here we will introduce the page 2112. Here is some combinations for the page 2112. So now we can see the first one is to the for the spare area distributes averagely on the sector. You should see the main area is 512 and the spare area is 16 and the main area is 512 and 16, 512 and 16. So you can see the spare area is distribution averagely on the sector. So here is the one page structure for 2112. The second one is the spare area is in the page tail. So we can see the main area is in the front of the page, and the spare area in the tail of the page. So here is the second page structure for 2112. And the third page structure, which you see here, is a page head. Here is a page head and a page tail in the page structure. Now we can see all the common page structure can be selected from the drop menu. So we can select what we want from the drop menu. So okay, so now I will show you how to analyze the raw data area. Okay, so first of all, we'll try to find the page. Okay, so first of all, we try to find the 55AA. So 55AA is a mark for MBR and DBR. And we will find that when we jumped the 512 bytes, then we can find, we call the 15 digitals as the spare part. So the 15 digitals could be the spare part for the flash chip. So here we can compare the two pictures. So the first pictures you can find 55AA. Then here is the spare part, right? Here is the spare part. The 15 digitals are the spare parts. Then we try to jump. We jump 512 bytes, and then we find another 15 digitals here. So we should know the page structure is 512 plus 16. So here is the page structure for this flash chip. Okay, so we have to jump to find the mark. The first find the 55AA, then we try to find the spare codes. Okay, so here is how to find the page structure. And then we will show you how to set the mark and ID correctly. And we have also to come back to the raw data. And when we change the page, here we can change the page from here. We can change the page from here. When we try to change the page, please note the data area. The page has been changed, right? Now we will find some data will be changed, and at the same time, we will try to find the regular change part from the service area data. So how to find the regular change? So here we should first find the mark. The mark should be the digitals that never be changed. So we should pay attention to the service data. We should note the digitals that have never been changed. So the digitals have never been changed is the mark of the flash. So for this case, we could see the 11 that never changed, right? So the 11 should be the mark of this flash chip. So how to fill the chart? Now here, the mark structure, the initial offset should be 1. You should calculate from here 1, 2, 3. So here 1, 1, 2, 3, right? Now 0, 1, 2. Now here is 2. So
offsets should be 2. And the size, here are 2 of them, right?
And then we will try to find the ID. So how to find the ID? So the ID will always change, but the change will be a regular change. We have to find the room during its change. So how to find the rooms?
So here is an ID. So the initial offsets you should calculate from here, 0, 1, 2, 3, 4, 5, 6. So the initial offset should be 6.
What is the difference between two of them? We introduce here. So the big endian means the front byte regular change slowly, and the little endian means the front byte regular change faster. So now you can find the ID have a regular change. And here is the ID order. The ID order has two kinds of ID order: is ascending order or descending order. So how to find the ID order is descending or ascending? Now here is the ID order, and the next is for the interleaf. So there could be some interleaf in the flash chips. So how to find if there is an interleaf? So we should find one way. Find the ID. The ID should change continuously.
Here is the page. So here is the standard page structures. The mark
will never change,
but the ID will change regular.
In all the flash pages, you can find it change. But the mark, you can find it never change in all the pages. So for this presentation, we will only focus